Alright, hi guys! For today's video, we are going to talk about trigonometric integrals. Trigonometric integrals strategies for evaluating sine, cosine, tangent, and secant. So we are going to talk about those strategies. First is strategy for evaluating, let's say, sine mx times cosine nx dx. The first strategy is when cosine is odd, need to save one cosine factor. We need to save one cosine factor and we will use this identity. Cosine squared x is equal to 1 minus sine squared x to express the remaining factors in terms of sine. Example number 1. Example for cosine. So what if I have an integral of cosine cube x dx? So the first condition is when cosine is odd, save one cosine factor. So that means we will rewrite this one and we will make this squared times cosine x dx, and use cosine squared x is equal to 1 minus sine squared x to express the remaining factors in terms of sine. So we will use that strategy. So cosine squared x is equal to 1 minus sine. 1 minus sine squared x times cosine x dx. Now, the next strategy is u substitution. So we will let u is equal to sine. Sine because we want to express the remaining factors into sine. So du, the derivative of sine is cosine. Cosine x, that would be x dx. Okay. The integral of 1 minus u squared cosine x, nor dx is du over cosine x. So this is times du over cosine x, and we'll cancel cosine. It's equal to the integral of 1 minus u squared du. Now let's solve for the integral. 1 is a constant, that means it's u minus 1/3 u cubed du. Substitute back what is u. U is equal to sine, so we have sine x 1/3 sine cube x plus some constant c. Now that is the final answer. Now for the second strategy, we have sine. Letter B. So we have sine. We have if sine is odd, save one sine factor and and use and use this identity. This is sine squared x is equal to 1 minus cosine squared x. Okay. Example. Here, example. Let's just do. Okay. What if I have the integral of sine 5x times cosine squared x dx. For the first condition, we will save one sine factor and use sine squared x is equal to 1 minus cosine squared x. So we will save one factor, so that means we have sine squared x squared, so that means sine to the fourth x times sin x cosine squared x dx. Now use this identity. So we know that sine squared x is equal to 1 minus cosine, so that means we have 1 minus cosine squared x squared times cosine, that is cosine squared x times sine x. And then we will use substitution rule. We let u is equal to cosine, because we wanted to express the remaining factors in the cosine. The derivative of cosine is negative sine x. Okay, so let's have 1 minus u squared u squared times sine x. Now our dx, let's have dx. Our dx here is du over, this is negative sine x, so this is negative du over sine x. So that means our sine will cancel, and we'll place negative here, so we are left with 1 minus u squared times u squared du. Forgot to write du. We will evaluate this one, so that will be 1 minus 2u squared, we will expand this one, plus u to the fourth times u squared du. And that is equal to, we will distribute u squared to this. So we have u squared minus 2u to the fourth plus u to the sixth du. And we will use power rule for this one. Power rule. So we have 1/3 u cubed minus 2u to the 5 over 5 plus u to the 7 over 7 plus some constant c. Now we will substitute back what is u. for u is cosine. So that means we have 1/3 cosine cube x minus 2/5 cosine 5x plus 1/7 cosine 7x plus some constant c. And don't forget we have negative outside. We almost forgot negative here, so we have negative. Oops. We have our negative here. So let us distribute the negative. So we have negative 1/3 cosine cube x plus 2/5